Hello, my name is Sangeeta Mahendra, and today I'll be presenting my project titled Will Your Flight Be Late? Predicting Delays with Machine Learning. This project explores how we can use machine learning techniques to forecast flight delays using historical and weather data. Here is a quick overview of what I'll be covering today. We'll start with the problem and motivation, explore the data set, go through uh, the model building, and then review the results, evaluation, and future works. Moving forward to introduction, flight delays are frustrating for passengers and airlines alike. Flight delays prediction is the process of using data to forecast if a flight will be delayed, helping airlines manage resource and travelers make better plans. A goal in this project was to build a predictive systems using historical flight and weather data to anticipate these delays. Okay. The main question, why predict flight delays? Why is this so much important? Here is an answer. Accurate prediction improves the passenger's experience by reducing uncertainty. Airlines can operate more efficiently by optimizing assignments and crew schedules. It also enables proactive response to weather or and supports data-driven decision making. In short, it's a win for efficiency and sustainability. Moving forward to the data set and the approach, the data set used comes from the Kagle and includes flight records from New York airports. That is the data set of JFK and the Newark from the year 2013. It contains detailed informations like flight numbers, schedules versus actual time, weather conditions, and the delay causes. This data allows us to identify the patterns and build our models under meaningful feature. Next slide, the data session. Before training the models, I cleaned and posed the data. I handled the missing values using median imputation. Categorical variable were encoded using label encoder. I scale numerical value using standard scalar. And additionally, I also created a new feature like time of day bins and flags for weekends and peak hours. The data set was split 80/20 into training and testing sets with sacrificed sampling. These are the data which I have been collected, and this was the process. And moving forward, model which I have been used, the machine learning models are like for modeling, I used five supervised classification algorithm. These are the five different algorithm which I've used. The first one is the logistic regression as a simple baseline. Next, second is the random forest and XGBoost, both unassembling methods. And next is a K nearest neighbors, which predicts based on proximity. And support vector machine, which finds the optimal boundary between classes. Each model brings a unique strength to the prediction task. Moving forward to the project overview, this slide outlines the complete workflow, data collection, followed by the proposing and feature engineering, then moving to model training, where each model was evaluated, and finally to real-time prediction, where the trained model can now make live delay predictions when fed with any new flight data. Next slide is evaluation metrics. Where to evaluate the models, I used accuracy, total correct predictions, and precision. How many predicted delays were actually delayed? Recall how many actual delays we correctly predicted. And the next one is F1 score, which is used to a balance between precision and recall. And the next one is AUC and ROC, that is nothing but area under curve, to assess the how well the model separate classes. And also we had used confusion metrics. This was an optional, but still for the visual purpose I had used it. These are the output which I've obtained from the Google Colab after uh, running all the codes over there. Here you can see the performance comparison XG boost at the highest performance with an accuracy of 88%, a precision of 81%, and the AUC of 0.91. A random forest and logistic regression followed closely. This result shows that methods like XGBoost are effective for this kind of structured data. I'll be explaining the code in the end of the after this once the slide is completed. Moving forward to the conclusion, to summarize, I built a machine learning system that can predict flight delays using both flight and weather data. I evaluated five models, and XG Boost performed the best out of all, comparing all five. The project demonstrated how data-driven methods can enhance airline operations and improve passenger experience. This was the main conclusion of this entire project. Moving forward to the future work. For a future enhancement, I plan to include a real-time weather feeds to make prediction dynamic. I'd like to deploy the model as a web app for airline or users. I also aim to explore deep learning models like LSTM, which are great for the subsequent data like flight history. Finally, early warning alerts for passengers could be built using this system. These are the main um, agenda and the work which I've done in this particular project. If I get a chance in rebuilding again this project, these are the future works which I'll be enhancement which I'll be